All right, welcome. Today we're going to talk about a tool that pretty much runs the entire world of modern software development, Git. If you've ever heard developers mention it and kind of felt like they were speaking another language, you are in exactly the right place. Let's dive in and figure this thing out. Oh man, does this look familiar? I think we have all been here. You're deep into a project, and suddenly your folder looks, well, it looks like this, a total graveyard of file versions. You're just trying to keep track of your changes, but you end up with this confusing mess, and you're terrified to delete anything, because what if it's the one version you actually need? It's pure chaos, right? It's stressful, and it's so easy to make a mistake. But what if I told you there was a system built from the ground up to prevent this madness? A system that millions of developers trust every single day to keep their work sane and safe? Well, there is. And that system is called a version control system, or a VCS for short. The core idea is simple. A VCS is a tool that records every single change you make to your project. So instead of you just saving the final file, it saves the entire history of your work, one change at a time. Honestly, the absolute best way to think about Git, which is the world's most popular version control system, is as a time machine for your work. Did you make a huge mistake? No problem. Just rewind back to the version from yesterday. Need to see exactly what changed last week? Git can show you, line by line. It gives you total control over your project's history.
So, how does this time machine actually work? Well, to really get it, we need to look at a few of its core concepts. Think of these as the fundamental building blocks that make everything else in Git possible. Let's break them down. First up, we have the repository, which everyone just calls a repo. You can think of it as your project's main folder, but it's way smarter than a normal folder. It doesn't just hold your files, it holds every version and every change ever made to those files. It's the complete database of your entire project. And this brings us to one of Git's most powerful ideas. It's distributed. So as you see here, you have a full, complete copy of the entire project and its history right there on your own computer. That's your local repository. Then there's usually a central version hosted on a server, the remote repository. This means you can work completely offline and you always have a full backup of the project right on your machine. Okay, so how do you actually save your work in Git? You don't just hit save. You make what's called a commit. A commit is basically a snapshot of your project at one specific moment in time. The analogy of a save point in a video game is perfect. It's a safe state that you can always come back to. Every commit gets its own unique ID and a little message explaining what you changed. Now, this next concept, this is one of Git's true superpowers, branching. A branch is, in essence, a separate timeline for your development. It lets you work on a new feature, or experiment with some crazy idea, or fix a bug, all in total isolation, without any risk of messing up the main, stable version of your project. You know what? Think of it this way. Creating a branch is like creating a parallel universe for your project. You can do whatever you want in that universe, break things, try new stuff, and the original timeline, your main branch, is completely safe and untouched. Then, when you're happy with your changes, you can merge that parallel universe back into the main one. It's an absolute game changer. Okay, so we've got the concepts down. Let's see how this all fits together in your daily work. For a lot of people, understanding this next part is the real aha moment with Git. It's a simple 3-step process for saving any change you make. So here's how it works. First, you just do your work. You change your files in your project folder. That's called the working directory. Step 2, before you save anything permanently, you add your changes to something called the staging area. This is like putting specific items in a shopping cart. You're carefully choosing exactly which changes you want to include in your next snapshot. And finally, you take everything in that staging area and you commit it, which saves that snapshot forever in your repository's history. And that staging area is the secret sauce. It gives you incredible control. You might have changed 5 different files, but maybe you only want to save the changes from 3 of them in one commit, because they're all related to a single new feature. The staging area lets you group your changes into small, logical commits that tell a clear story, which makes your project history so much easier to understand down the line. So far, we've mostly talked about how you'd use Git on your own, but its real magic, its true power, shines when you start working with a team. So let's look at how Git makes that collaboration totally seamless. It really boils down to 2 simple commands, push and pull. When you've made a few commits on your local machine and you're ready to share that work with your team, you push those changes up to the remote repository. And when you want to get the latest updates that your teammates have made, you pull their changes down from the remote repository into your local copy. It's a really simple, elegant way to keep everybody's work in sync.
So you might be wondering, where does this remote repository actually live? I mean, it's got to be on a server somewhere that the whole team can get to, right? And that's exactly what Git hosting platforms are for. You've almost certainly heard of these guys. GitHub is the undisputed giant. It's the heart of the open source world. Then you have GitLab, which is more of a complete all-in-one platform for the entire software lifecycle. And there's Bitbucket, which is really popular for its tight integration with other tools like Jira. They all give your remote repo a home and add a bunch of powerful collaboration features on top.
Whew, okay, we have covered a lot of ground. So let's zoom out and put a bow on this. Why has Git become so incredibly dominant? What are the key features, the real superpowers that make it an absolutely essential tool for modern development?
So what are Git's superpowers? Well, first, it's distributed, which means everyone has a full history, which is great for backups and working offline. It's incredibly secure, using some clever math to protect your project's history from being tampered with. And, like we've seen, it enables unbelievable collaboration through branching and merging, all while giving you that time machine power to undo any mistake and track every single change ever made.
And that's exactly why you see statements like this everywhere. Learning Git isn't just about picking up a new piece of software. It's about learning the fundamental workflow for how modern digital projects are built and managed by teams all over the world. So, as we wrap up, I'll leave you with a final thought. Git created this revolutionary model for collaboration that brought order to the chaos of software development. But the core principles, tracking changes, branching off new ideas, merging contributions back in, those are universal. It really makes you wonder, what other fields, from legal documents to scientific research, even creative writing, could be totally transformed by this same powerful idea? Something to think about. Thanks so much for watching.